ಪ್ರೀತಿ ವಿದ್ಯಾರ್ಥಿಗಳೇ, DC machines and alternators, one of the subject in your third semester. ಇದರ ಯೂನಿಟ್ 1 ಅಲ್ಲಿ ನಾವು ಇವಾಗಲೇ DC ಜನರೇಟರ್ ಬಗ್ಗೆ, ಅದರ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಬಗ್ಗೆ, ಸ್ಟೇಟರ್, ರೋಟರ್, ಸ್ಟೇಟರ್ ಡಿಫರೆಂಟ್ ಪಾರ್ಟ್ಸ್, ರೋಟರ್ ಡಿಫರೆಂಟ್ ಪಾರ್ಟ್ಸ್, ಹೇಗೆ DC ಜನರೇಟರ್ ಅಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಜನರೇಟ್ ಆಗ್ತದೆ, ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ DC ಜನರೇಟರ್ಸ್, shunt generator, series generator, compound generator, short shunt compound generator, long shunt compound generator, separately excited DC generator, self excited DC generator ಇದ್ರ ಬಗ್ಗೆ ಎಲ್ಲ ತಿಳ್ಕೊಂಡಿದ್ದೀವಿ. ಸರ್ಕ್ಯೂಟ್ ಡಯಾಗ್ರಾಮ್, EMF ಇಕ್ವೇಷನ್, ಡೆರಿವೇಷನ್ಸ್, ಎಕ್ಸಾಂಪಲ್ಸ್ ಕೆಲವೆಲ್ಲ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದೀವಿ. DC ಜನರೇಟರ್, ಸಿಂಪಲ್ ಲೂಪ್ ಜನರೇಟರ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ದೀವಿ. ಆರ್ಮೇಚರ್ ವೈಂಡಿಂಗು, ಲ್ಯಾಪ್ ವೈಂಡಿಂಗು, ವೇವ್ ವೈಂಡಿಂಗು, ಕಂಪಾರಿಸನ್ಸ್ ಎಲ್ಲ ತಿಳ್ಕೊಂಡಿದ್ವಿ. ಸೊ ಒನ್ಸ್ ಅಗೇನ್ ವೆಲ್ಕಮ್ ಟು DC ಜನರೇಟರ್ ಸಬ್ಜೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ ಯೂನಿಟ್ 2. In a generator, EMF equation EG equal to phi Zn by 60 P by A, where phi is the flux in Weber, Z is total number of conductors, N rotor speed, P number of parallel path, A number of parallel path, P number of poles. ಅದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಪ್ರಾಬ್ಲಮ್ಸ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಇನ್ ದಿಸ್ ಕ್ಲಾಸ್ ಆರ್ಮೇಚರ್ ರಿಯಾಕ್ಷನ್ ಬಗ್ಗೆ, ವೆರಿ ನ್ಯೂ ಟಾಪಿಕ್. ಸೊ ಕೇರ್ಫುಲ್ ಆಗಿ ತಿಳ್ಕೊಳ್ಳಿ. ಇದರಲ್ಲಿ ಆರ್ಮೇಚರ್ ರಿಯಾಕ್ಷನ್ ಅಂದ್ರೆ ಏನು, ಕ್ರಾಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಫೆಕ್ಟ್, ಡಿಮ್ಯಾಗ್ನೆಟೈಸಿಂಗ್ ಇಫೆಕ್ಟ್ ಬಗ್ಗೆ ಎಲ್ಲ ತಿಳ್ಕೊಳ್ಳಿಕ್ಕಿದೆ. ಸೊ ಕೆಲವು ವಿಷಯವನ್ನು ಇಲ್ಲಿ ನೋಡುವ. ಇದು DC ಜನರೇಟರ್, ಸ್ಟೇಟರ್, ಔಟರ್ಮೋಸ್ಟ್ ಯೋಕ್, ಸ್ಟೇಟರ್ ಪೋಲ್, ಪೋಲ್ ಶೂ, rotor, inside the rotor slot, different rotor conductors. This is the Fleming's right hand rule. First 3 fingers of right hand, thumb, forefinger, middle finger perpendicular to each other. Keep the thumb in the direction of motion of the conductor, forefinger in the direction of flux, then middle finger indicates the direction of current. This is the generator rule. Here in the conductor, if you mark dot, then current is away from the screen or away from the page anta artha. Cross or plus idre current is toward the screen or toward the page. Also we studied current carrying conductor produces the flux. Right hand thumb rule, thumbs up rule. If you hold the current carrying conductor in our right hand, if you extended them in the direction of current, then folded fingers indicate the direction of flux. ಇದೆಲ್ಲ ನಾಲೆಜ್ ಬೇಕಾಗ್ತದೆ ಇದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ. ಇಲ್ಲಿ ನೋಡಬಹುದು, ಸ್ಟೇಟರ್ ಇಂದ ಫ್ಲಕ್ಸ್ ನಾರ್ತ್ ಇಂದ ಸೌತ್ ಗೆ ಬರ್ತದೆ, ರೋಟರ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆದಾಗ ಏನಾಗ್ತದೆ ಅಂತ. What is armature reaction? Armature reaction is the effect of armature flux over the distribution of the main flux. So main flux is flux produced by the stator field winding, north and south poles electromagnetic field. So if armature conductor cuts that flux, EMF is induced in the armature conductor according to Faraday's laws of electromagnetic induction. Then if current carrying conductor also produces flux, so armature conductor also produces the flux. This armature EMF induced in this armature conductor, current carrying conductor produces flux, so this armature conductor also produces the flux. This is the armature flux. So effect of this armature flux on the main flux is the armature reaction. It's very important point. Armature flux is the flux which is produced by the armature conductors due to the current flowing through them. Armature conductor ಅಲ್ಲಿ current ಹರಿಯುವಾಗ ಅದು produce ಮಾಡೋ flux armature flux. Main flux is the flux which is produced by the poles which is necessary for the operation. When the generator is not loaded, there is there exists only main flux Fm. When generator is loaded, armature conductor carries current and produces Fa, which will distort the main flux, and this phenomenon is called armature reaction. That means Fm means flux from the main field, Fa armature flux. It cross magnetizes the main flux, resulting sparking across the brushes. Armature flux and main flux cross magnetize agi spark ಬರ್ತದೆ brush ಅಲ್ಲಿ. Also it demagnetizes the main flux, resulting reduced voltage. This armature flux ಇಂದಾಗಿ main flux reduce ಆಗ್ತದೆ, so EMF induce ಆಗೋದು ಕಡಿಮೆ ಆಗ್ತದೆ. Some terminologies practice ಮಾಡ್ಕೊಳ್ಬೇಕು ಇದರಲ್ಲಿ. ಏನಂದ್ರೆ ಫಸ್ಟ್ polar axis ಅಂದ್ರೆ ಏನಂತ. It is the imaginary line which joins the center of the north and south poles. The north pole to south pole. ಒಂದು ಲೈನ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ ಅದು polar axis ಅಂತ. Polar axis. Next GNA, geometrical neutral axis. ಎಲ್ಲರಿಗೂ ಕೇಳ್ತಾ ಇದೆಯಲ್ಲ? Geometrical neutral axis. ಇದು vertical here GNA ಅಂತಿದೆ ನೋಡಿ. It is the axis which divides the armature core into equal parts. Armature ಇದು ಸೆಂಟ್ರಲ್ಲಿ ಒಂದು ಲೈನ್ ಹಾಕಿದ್ರೆ ಅದೇ geometrical neutral axis ಅಂತ. Next very important, magnetically neutral axis MNA. It is the axis along which EMF is produced, along with which no EMF is produced. Hence brushes are kept on this axis. MNA is always perpendicular to main flux. So in this example, north pole to south pole, main flux. So perpendicular to that is the MNA, magnetic neutral axis. So here no induced EMF, so no flux is induced. This axis is called magnetic neutral axis. Here both GN and MNA coincides, but not in the actual case. Leading pole tip and trailing pole tip. The tip of the pole which is first met by the armature conductor during its rotation. Rotate ಆಗ್ತಾ ಇರುವಾಗ clockwise rotate ಆಗಿದ್ರೆ first tip ಇದು leading pole tip ಅಂತ ಹೇಳ್ತಾರೆ. ಆಮೇಲೆ ಕೊನೆಯಲ್ಲಿ ಸಿಗೋದು trailing pole tip. ಇಲ್ಲಿಯೂ ಅಷ್ಟೇ leading pole tip, trailing pole tip. The tip of the pole which is met by the conductor at the end of the direction of rotation is trailing pole tip. Consider a 2-pole DC generator. When it is not loaded, one pole north pole, south pole, stator, the rotor, brushes, here armature conductors. Assume that there is no current flowing through the armature conductors, hence the flux is distributed symmetrically with respect to polar axis. The MNA coincides with the GNA in this case. This main field left to right, magnetic neutral axis vertical at no load. MNA and GNA are coincides here. Brush fixed here. You can see all the parts here. Here without load, no armature current. Next, when armature is loaded, that means generator is loaded. What happens? Rotor rotates in the clockwise direction. Load current flows through the armature conductors. Direction of current is as shown. Here, cross sign means current toward the screen. Here, dot means current away from the screen. Next, flux due to this is, if you hold the right hand thumb rule, current is towards, so here clockwise, left side, here clockwise flux. Here flux due to the current carrying conductor is anti-clockwise, away from the screen. Now due to the current flowing through the armature conductors, magnetic flux is produced around the armature conductors According to the right hand thumb rule, the direction of the flux is clockwise in the conductor which are influence of north pole, and anti-clockwise conductors and anti-clockwise in conductors which are influence of south pole. Armature flux FA is crossing the main flux. This is left to right main flux. So 90° to this is armature field. Next, the combined effect of these two. Main field is distorted. Flux near the leading pole tip is weakened. Flux near the trailing pole tip is stronger. See, combined effect here, flux is left to right, main flux, armature flux is upward. So total flux increases here, but here armature flux down. So comes like this. ಹೀಗೆ ಮೇಲ್ಗಡೆ ಹೋಗಿ ಕೆಳಗಡೆ ಬರ್ತದೆ, ಪುನಃ ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಹೋಗ್ತದೆ. Same cumulative effect of armature flux and main flux like this, then decreases, comes like this, then once again here. This is two flux effect. Now magnetic neutral axis is slightly shifted by an angle theta. So MN is shifted. Geometrical neutral axis remains same. That means neutral. No EMF induced in the conductor placed at this position. So you have to fix the brushes at this position at an angle theta. This is magnetic neutral axis. Now resultant flux is the vector sum of the main flux and armature flux. Hence the position of the MNA changes, which is always perpendicular to the resultant flux. Due to change in the position of MNA, sparking occurs at the brushes. Brushes are given forward lead by an angle theta. ಇದೇ ಪೊಸಿಷನ್ ಬ್ರಷ್ ಇದ್ರೆ ಸ್ಪಾರ್ಕಿಂಗ್ ಬರ್ತದೆ. ಸೊ ಸ್ವಲ್ಪ ರೊಟೇಟ್ ಮಾಡಿ ಬೇಕಾಗ್ತದೆ. ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಬ್ರಷ್ ಇಡಬೇಕು. ದಿಸ್ ಆಂಗಲ್ ಇಸ್ ಥೀಟಾ. ಸೊ ಮೈನ್ ಫ್ಲಕ್ಸ್ ಇಸ್ ಹಿಯರ್. Armature flux combined due to this magnetic neutral axis shifted. So armature flux now direction is like this after rotation of the brushes. See here, in this the magnetic neutral axis, FA is like this. If you divide the FA into two parts, one is horizontal part and vertical part. This is the demagnetizing flux, horizontal part. Vertical part is cross magnetizing flux. Now due to brush shift, armature conductors and hence armature current is redistributed. Hence FA is no longer vertically downward but shifts by an angle theta. FA is resolved into two components, FD and FC. FD is a demagnetizing component, FC is the cross magnetizing component. Demagnetizing component andre ಇದು opposite, directly opposite ಮಾಡ್ತದೆ. Main flux left to right ಇದ್ರೆ ಇದು right to left. Due to this total flux reduces, so total EMF also reduces. But cross magnetizing is 90° to the main flux. So due to this sparking occurs at the brushes. When generator is not loaded, no armature reaction. Conclusions: with brushes located along GNA, there is no demagnetizing component. There is only cross magnetizing effect. With the brushes shifted to GNA, armature shifted from GNA, armature reaction will have demagnetizing and cross magnetizing effect. The demagnetizing component of armature reaction weakens the main flux. Cross magnetizing component of the armature reaction effect is leads to sparking at the brushes. Next, demagnetizing and cross magnetizing conductors. Around the armature, totally armature conductors on the outer periphery. Shifting angle is theta. So this side theta and this side theta. See, conductor placed between this area AOC in the upper portion, at the same time in the lower half DOB or BOD. The conductor placed between these two areas is demagnetizing conductors. Similarly, others area also you can see here. The armature conductors lying within the AOC and BOD, totally 2 theta, are responsible for demagnetizing effect. These are called demagnetizing armature conductors and constitute the demagnetizing ampere turns. The axis armature conductor lying between the AOD and COB responsible for cross magnetizing effect. That means AOD and BOC illiro conductors, these conductors and these conductors has a cross magnetizing effect. Illiro conductor and illi current conductors AOC and BOD demagnetizing conductors. Therefore, they are called cross magnetizing conductors and constitute the cross magnetizing ampere turns of armature reaction. Next, formula for demagnetizing and cross magnetizing ampere turns per pole. Let Z total number of armature conductors, P number of poles, I armature conductor current in amperes, IA by 2 for simplex wave winding, IA by P for simplex lap winding. Because number of parallel path equal to 2 for wave winding, number of parallel path equal to P for lap winding. Theta M equal to forward lead of brush in mechanical degrees. Theta mechanical, there is a relationship between electrical degree and mechanical degree. Mechanical degree equal to electrical degree divided by pair of poles equal to theta electrical by P by 2 or 2 theta electrical by P. Also electrical degree, theta electrical equal to P by 2 or pair of poles into theta mechanical, or theta mechanical equal to theta electrical by P by 2. That means in case of two pole machine, electrical degree equal to mechanical degree. That means 180 degree rotation means half rotation equal to both in electrical mechanical same. In 4 pole machine, P by 2 is 2. That means 180 degree rotation in mechanical half round equal to 360 degree rotation in electrical. That means one complete cycle. So you have to remember all those things. Demagnetizing ampere turns per pole equal to Zi into theta divided by 360 degree. This is the formula for demagnetizing ampere turns per pole. Cross magnetizing ampere turns per pole equal to Zi whole into 1 by 2 P minus theta divided by 360. So this is the demagnetizing ampere turns formula. This is the cross magnetizing ampere turns formula. Next, we will, based on this knowledge, multiple choice questions ಸ್ವಲ್ಪ ನೋಡುವ. Brushes are always placed on dash in order to achieve sparkless commutation. Brushes ಅನ್ನು ಎಲ್ಲಿ ಇಟ್ಟಿರ್ತೀವಿ? Geometrical neutral axis ಅಲ್ಲ, magnetic neutral axis ಅಲ್ಲ, ಅಥವಾ either GNA or MNA or none of the above. ಯಾವ axis ಅಲ್ಲಿ ಅಂತ ನೀವು ಗೊತ್ತಿದೆ ಅನ್ಕೊಂಡಿದ್ದೇನೆ. Next question. Result of demagnetization effect is dash. Demagnetization effect ಇಂದ ಏನಾಗ್ತದೆ ಅಂತ, commutation effect ಆಗ್ತದ, reduction in the main field flux, reduces the terminal voltage, ಅಥವಾ B and C ಎರಡು ಆಗ್ತದ ಅಂತ. Next, armature reaction flux density under trailing pole tips in case of generator will increase or decrease, either increase or decrease or none of the above ಅಂತ. Similarly, armature reaction, in armature reaction, flux density under leading pole tips in case of generator will increase, decrease, either increase or decrease or none of the above. ಸರಿಯಾಗಿ ಅರ್ಥ ಮಾಡಿಕೊಂಡು ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು. Which axis undergoes shifting as a result of armature reaction? GNA ಶಿಫ್ಟ್ ಆಗ್ತದ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಶಿಫ್ಟ್ ಆಗ್ತದ, ಅಥವಾ ಎರಡು ಶಿಫ್ಟ್ ಆಗ್ತದ, ಅಥವಾ remains fixed ಆಗಿರ್ತದ ಅಂತ. In DC generator, armature reaction is actually produced by field current, armature conductors, field pole winding, load current in the armature. ಯಾವುದರಿಂದ armature reaction ಆಗ್ತದ ಅಂತ. In DC generator, the effect of armature reaction on the main pole flux is to reduce it, distort it, reverse it, both A and B. In a 6-pole DC machine, 90 mechanical degree correspond to dash electrical degree. Formula now study ಮಾಡಿದ್ವಿ. Electrical degree equal to P/2 into mechanical degree. Based on that, you have to convert 30, 180, 45, 270. In a clockwise rotating loaded DC generator, brush have to be shifted. Clockwise shift ಮಾಡಬೇಕಾ, counter clockwise, anti clockwise, so either A or B, so neither A nor B. The main reason of drop due to armature reaction in this generator is armature flux due to armature current, load current, shunt and series field current, none of this. The conductors which will cause distortion in the main field flux of this machine are demagnetizing armature conductors, cross magnetizing, both A and B, none of these. ಇದಕ್ಕೆ ರೆಫರೆನ್ಸ್ ಆಗಿ ತಗೊಂಡಿರೋದು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಟೆಕ್ನಾಲಜಿ ವಾಲ್ಯೂಮ್ 2 BL Thareja and AK Thareja. Also Principles of Electrical Machines by VK Mehta. Prescribed textbooks in your syllabus. ಇದರ ಬಗ್ಗೆ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ವಿಡಿಯೋವನ್ನು ನೋಡಬಹುದು. ಈ ಲಿಂಕ್ ಅಲ್ಲಿ ಕ್ಲಿಕ್ ಮಾಡಿದಾಗ ವಿಡಿಯೋವನ್ನು ನೀವು ನೋಡಬಹುದು. ಸೊ ಆರ್ಮೇಚರ್ ರಿಯಾಕ್ಷನ್ ಬಗ್ಗೆ ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾವು ರಿವೈಸ್ ಮಾಡಿದ್ವಿ. ಅದರ ಇಂಪಾರ್ಟೆಂಟ್ ಟರ್ಮ್ಸ್ ಕೆಲವರ ಬಗ್ಗೆ ಎಲ್ಲ ತಿಳ್ಕೊಂಡಿದ್ವಿ. GNA, MNA, ಪೋಲಾರ್ ಆಕ್ಸಿಸ್, ಥೀಟಾ, ಕ್ರಾಸ್ ಮ್ಯಾಗ್ನೆಟೈಸಿಂಗ್ ಇಫೆಕ್ಟ್, ಡಿಮ್ಯಾಗ್ನೆಟೈಸಿಂಗ್ ಇಫೆಕ್ಟ್, ಕ್ರಾಸ್ ಮ್ಯಾಗ್ನೆಟೈಸಿಂಗ್ ಕಂಡಕ್ಟರ್, ಡಿಮ್ಯಾಗ್ನೆಟೈಸಿಂಗ್ ಕಂಡಕ್ಟರ್ ಇದ್ರ ಬಗ್ಗೆ ಎಲ್ಲ ತಿಳ್ಕೊಂಡಿದ್ವಿ. ಕೀಪ್ ಆನ್ ಲರ್ನಿಂಗ್. ಆಲ್ ದಿ ಬೆಸ್ಟ್.